Hey guys, today we have LeetCode 1673, find the most competitive subsequence. We'll be given an array of integers nums and an integer k, and we have to return the most competitive subsequence of size exactly k. Most competitive subsequence is just a fancy way of saying the lexicographically smallest subsequence or the lexicographically first subsequence. For this array and k equal to 4, the answer is the subsequence 2, 3, 3 and 4. Now we could do this very easily by generating all the subsequences of size k, sorting them in lexicographical order and then returning the first of the sorted subsequences. But the problem is, generating all the subsequences of size k will take exponential time. The constraints given in the problem tell us that the length of the array and the value of k can be as large as 10 raised to the 5th, so by no means can we afford exponential time. Let's see if we can come up with anything better. We know that we have to come up with the lexicographically smallest subsequence of size k. So we can start at the first element and scan the array for the smallest element. In this case, the smallest is 2, so we add that to the subsequence. Now the length of the subsequence is 1, so we need to find 3 more elements. We have already included 2, so we cannot include that 2 again or any element before it. We can only include the elements after 2 since we have to construct a subsequence, so order matters. Once we pick an element and add it to the subsequence, all the remaining elements we pick have to be from after that element. So let's start at 3 and find the smallest element in the remaining portion of the array. In this case, it just happens to be 3 itself. We add that to the subsequence. Next, we do the same to find the third element and we find the other 3 as the smallest element and add it to the subsequence. Finally, we do it for the fourth element and we get our subsequence, which is 2, 3, 3 and 4. So that's seems straightforward enough. We find the minimum element in the array that lies after the last element we picked. We add that element to the subsequence. We do this procedure k times. That's good. But as it turns out, right now this method has a really big flaw. Consider this example. It's the same as the previous example except I just changed the last element to 1. We start off by finding the minimum element, we find the 1 and we add it to the subsequence. Now we have run into a problem. We still have to add 3 more elements to the subsequence, but we can't do that now, right? Because we have already reached the end of the array. So if we put 1 as the first element of the subsequence, we will not be able to construct a subsequence of length 4. Let us modify the algorithm a little to take care of this problem. First, we'll keep track of the current length of the subsequence. Okay, if the length of the subsequence right now is 0 and we know that we need a total of 4 elements, it means that we cannot choose any of the last 3 elements to insert into the subsequence. Because if we were to choose any of these 3 elements right now, we will not be able to complete the subsequence of size 4. So right now our searching window for the minimum element is just the first 5 elements. We search in that window, we find the minimum element as 2 and we add it to the subsequence. Next, when we are trying to find the second element to add to the subsequence, we find the minimum starting after the 2 and excluding the last 2 elements. In general, we exclude the last k minus l minus 1 elements while finding the minimum. In this case, we find the minimum to be 3 and we insert it into the subsequence. The basic idea is we exclude the last k minus l minus 1 elements while searching for the minimum element. By repeating this procedure 2 more times, we'll be able to generate the required subsequence, which is 2, 3, 3 and 1. Let us add this modification to the algorithm. Okay, so whenever we are searching for the minimum element, we don't consider the last k minus l minus 1 elements into the search. Now, the time complexity for finding the minimum element is big O of n and we'll be running this operation k times. So the time complexity of this algorithm is big O of k into n. We can actually get this down to linear time. Let's see how. We are trying to find the minimum element each time and we know how to do that in linear time, right? But we also have to simultaneously keep track of the subsequence and keep adjusting the elements. We can do this using a stack. Now we start traversing from the first element and for each element we check if that element is smaller than the top of the stack. If it is smaller, we then pop from the stack until the top of the stack is smaller than the current element of the array, after which we push the current element into the stack. Right now there is nothing in the stack, so we can't check for anything. We'll just push the element into the stack. Next, we move on to the second element in the array, this time we find that it is smaller than the top of the stack. So we pop from the stack and then push the 2 into the stack. Then we come to the 3. It is greater than the top of the stack, so we just push it into the stack. We do the same for the next 3, and similarly we push the 5 into the stack. When we come to the 4, we see that 4 is smaller than the top of the stack. We pop from the stack. Now 3 is at the top of the stack and it is smaller than 4. So we don't pop anymore and we just insert the 4 into the stack. Next we come to the 9. 9 is greater than the top of the stack. Okay, so we don't have to pop the 4. But the question is, do we really need to insert the 9 into the stack? See, we already have 4 elements in the stack and we only need 4 elements. Now these are not the final 4 elements. They may change as we keep traversing, but there is really no point in pushing the 9 into the stack because 9 is greater than the top of the stack and we already have 4 elements in the stack. So we will not gain anything from pushing the 9 into the stack. Hence we do nothing and move on to the next element. Finally we come to the last element, which is 1. It is smaller than the top of the stack, so we pop. Then we get 3 at the top of the stack. 3 is also larger than 1, but we cannot pop it. Right now the size of the stack or the length of the subsequence is 3. If we pop the 3 from the stack, the number of elements remaining will be 2. Remember, we need to get a subsequence of size 4. Since 1 is the last element of the array, if we have less than 3 elements in the subsequence right now, we will not be able to get a subsequence of size 4. In general, we are only allowed to pop from the stack if n minus I is greater than k minus l. Here n is the size of the given array and I is the current index we are at. The index I is 0 based. In this case, the condition does not hold, so we cannot pop anymore. Hence, we just push the 1 into the stack, and finally the stack contains the elements 2, 3, 3 and 1, which is indeed the subsequence we were looking for. So the algorithm we get is as follows. We traverse the entire array. For each element, we check if the top of the stack we are maintaining is greater than the current element, and we have at least k minus l elements remaining in the array after the current element. Then we pop the element at the top of the stack. Here l is the current size of the stack. As long as these two conditions hold, we keep popping from the stack. Next, if the size of the stack is less than k, we push the current element into the stack. If the size of the stack has already reached k, we have no need for pushing the current element into the stack. And then we continue traversing. The time complexity of this approach is just big O of n. We do have a while loop nested inside the traversal loop, but the most operations we'll ever perform would be if we inserted every element into the stack and popped all the elements, just leaving a single element in the stack at the end. That's the worst case, and that's still big O of n, and hence the time complexity of this entire method is big O of n. Alright, let's get into the code. Here we are writing Python first. This is the code we are given to begin with. Let's create our subsequence as an empty list. This is a list, but we'll be treating it as a stack. Next, we initialize I to -1. We'll use I to track the index of the current element we are at. Then we start traversing over the array. Inside the loop, we first increment I. Then, while the last element in the subsequence is greater than the current element we are at, and we have at least k minus the length of the subsequence elements remaining in the array, we pop the last element of the subsequence. After the while loop, if the length of the subsequence is less than k, we push the current element into the subsequence. Once we are done iterating over the array, we return the subsequence we have generated. Now I'll copy this and paste it into LeetCode. Runs fine on the example test cases, and we have a successful submission. Okay, let's write the C++ code for this. We have this code initially. Let's declare a vector of int to store the subsequence. In the explanation, we used a stack. We could do that here as well, but I have just chosen to go with a vector since the function has to return a vector, so it's just simpler that way. We'll treat this vector like a stack, that is, we'll only push and pop from the back. Next, we traverse over the nums array. The first thing we do is check and pop elements. While the last element of the subsequence is greater than the current element we are at, and nums.size minus I is greater than k minus the size of the subsequence. That is, we have enough elements remaining to complete the subsequence of size k. If these conditions are true, we remove the last element from the subsequence, and we keep doing so until these conditions hold. Now, if the size of the subsequence is less than k, we push the current element into the subsequence. After exiting the for loop, we return the subsequence we have generated. Let's copy this and run it on LeetCode. Example test cases went fine, and we have a successful submission. Alright guys, thank you so much for watching. Please subscribe, it will really help support the channel. Like the video if you found it helpful, and do leave your feedbacks in the comments. I'll see you next time.